So this is not a completely new topic for this conference, because last year Chris Tyler already reported on ILP32 performance on ARM64. Since last year, there is, as we think in Llvm, there is significant progress on ILP32. So I want to refresh the status here. So briefly, what execution modes ARMv8 supports right now. The original 64-bit execution mode is ARM64. Here is integer is 32-bit length, and the long and pointer types 64-bit length. Also, ARM supplies ARM33 IP core, which is originated to provide binary compatibility to ARMv7 and earlier CPUs. In ARM33, all integer long and pointer types are 32 bits. That's for it called ARM33. And ILP32 mode also has integer long and pointer 33 bits. That's why ILP32. And what the difference? So difference is that ARM33 is a IP core for binary compatibility. It means that it takes transistors from CPU and provides hardware compatibility. It's easier from software development point of view, because if you want to run a 32-bit application on Linux system, you don't need even to recompile it, only add the support to Linux 64-bit Linux kernel. In opposite, ILP32 is true ARMv8 execution mode. It means that it uses ARMv8 instruction set and gets all benefits from it. Also, it doesn't need a ARM33 IP core, and it means that potentially we can supply more cheaper devices, because less transistors, and that's all. And because we use modern instruction set, we should, in theory, achieve better performance results on tests and so. That's why we work on ILP32. So ILP32 should potentially be better, but it takes more efforts from software engineers, because because more components should be ILP32 ready to make things work. And in last year we get significant progress on it. And the main component is binary interface between kernel and user space. Now we have agreement on kernel community and glibc community how things should work, and we have Linux kernel patches supplied, sent to kernel list, and also glibc patches. GCC at now supports ILP32 with exceptions of few patches that we have in Llvm, but we plan upstream it soon. LLVM, we also work on it, and currently multi-library support in LLVM is ready, and we continue work. Binary utils and GDB patches are also upstreamed, and you can find it in new 2.28 release of binary utils. Also, there are developers tools like Valgrind and ILP32 full-featured distributions that is in progress. So now we are going to implementation details. Originally, it was idea to make a software analog of ARM32 execution mode. During discussion in kernel list, we decided to make ILP32 is not like ARM33 or ARM64, but the standard compatible architecture as much as possible. So we, on kernel side, we use all standard types with two exceptions, real-time RT6 frame and GREX set, because on kernel point of view, ILP32 program is almost like true ARMv8 program, but on user space side, this is 32 program and utilizes all 33 registers. On user space, we have all user types like in regular 32-bit architecture, with exceptions of that ones. This is because ILP32 is modern 32-bit architecture, and we should follow all requirements for modern architectures, and that types like offset and INOT, they should be all 64 bits on modern architecture. You cannot...
Just a clarification there. These types, the kernel already supports both 32 and 64-bit types on the kernel to user space interface. It's just that the glibc default for ARMv7 and AR32 uses 32-bit on those types, and the new glibc uses 64-bit for those types on all 32-bit architectures.
Yes, you cannot find time type here, turn it to 64-bit, because time T is a special story, and there is a long effort to make kernel and glibc ready to 2038 year. So ILP32 will wait generic solution for time T. Next one, system calls. Almost all system calls are taken from standard compatible layer, with exceptions of that ones. Most of them because ILP32, most of them are those who take 64-bit arguments, and ILP32 requires to take that argument in a register pair, so like ARM63. The rest of them are taken from standard compatible and ARM64 layers. If you need details, maybe you can give me a question and I will answer. So coming to testing results. Recently we achieved a zero fail rate on a Linux testing project, and I'm proud of it. Also, I ran Trinity for almost a weekend and found the kernel survived after it. If you don't know, Trinity is a system call fuser that passes the crap to the kernel. On glibc, this is measurement by Steve Elsey. On glibc, we have 3 extra failures comparing to LP64 mode, and one failure that one test that fails for LP64 is passed in ILP32. So results are pretty good. On GCC, there is a set of failures, but we think that some of them are due to our testing system rather than ILP itself. Find details on the link provided below. Binary utils, there are no fails related to ILP32, and we, during development, we also added about 14 tests to the test suite. For GDB, there are 77 failures in LP64 of 30,000 more, and 223 failures in ILP32. This is more failures, but the architecture is very young, and I think it's possible at this age. Without?
I mean, how many test failures in GDB without ILP32? I mean, the vanilla
without ILP32, you
yes,
mean?
Yeah, without your patch.
You mean LP64?
Yes, no, V8, ARM64.
77 failures in LP64 mode, and 223 failures in ILP32 mode.
No, I mean without ILP32 patch.
Yeah.
It's not changed.
ILP32 doesn't affect
Okay.
fail rate of LP64. This is
Just to clarify, so the GDB results on V7 are the same failure or different failures? You don't know?
I don't know.
But that might be a good thing. Like, just for completeness, I don't think it's really important, but it might be that a 64-bit kernel running the AR32 user space also has a significant number of failures that are the same as the ILP32 failures in 32-bit binaries. Okay. Yep. Okay.
So this was answered for GDB, but as a general rule, does ILP32 patch set added to the kernel affect in any way correctness-wise LP64 runtime?
I think no. We didn't run a special test, but we ran LP64 system overall kernel LP64 and Linux distribution LP64. So if I change something in kernel and it affects execution of LP64, just Linux will crash on somewhere on user space or in kernel. So I believe no, but I didn't run a special test. If you're really interested in it, I can do it later after the conference.
So I think the main areas that are patched at all are the signal handling and ptrace interfaces. So if anything changes, that would be one of those two.
I think the ptrace part is okay, but the additional, I think, two interface rate here, as far as I know, is from the signal handler. So GDB has to match the instructions in the signal handler. I suspect to change that part and we cannot match the signal handler. So that holds the 200. That's my understanding of it.
Okay. So this is performance section. On this slide, you can see spec CPU test that we ran for CN99 and CN88 Llvm ThunderX devices. First two bars is CN99 new device, single core and rated tests. And second one is CN88 device. Positive values means that ILP32 is faster. Negative values means that LP64 is faster. So you see that generally ILP32 is faster. We think it's because the new instruction set is working better on new kernel, and compact application works better with caches and memory subsystem. Maybe there are other.
You've got no results there for V7, so it's not really a like-for-like comparison. I suspect most of these numbers come from the fact that you're using smaller pointer size.
Yeah.
And a very tiny amount will come from a slightly better ABI, very little from the ISA itself.
The spec CPU is not ABI because this is not. There are not so much system calls to kernel. This is more about.
I'm talking about the procedure call standard ABI. So the fact that you've got more registers and more registers for parameter passing.
Yeah. Yes, there are too much.
It'll only be a second order effect.
Yes, there are too much reasons to make ILP32 faster here. Anyway, the average performance gain is more than 8%. So 8% just because we moved to ILP32. If your application is time critical and doesn't need full virtual memory layout, you can recompile it in ILP32 and get about 8% performance gain. There is also concern about if ILP32 patches affects the performance of LP64 native mode in Linux. So this slide is about it. Negative low bar means better, and yellow bar is vanilla Linux kernel. Red bar is means that ILP32 patch is applied but disabled in kernel, and blue bar means ILP32 are applied and enabled, but all these tests for LP64 mode. So we can see that ILP32 doesn't affect LP64 mode too much, and in some cases, like in null test and start test in LMBH10 suite, LP64 running with LP32 enabled show little better result, 3–4%, no more.
You are benchmarking LMBH
Yes.
as a program in LP64
Mm-hmm.
API.
Ah,
And what do you do with ILP?
it was concerned in mailing list that ILP32 negatively affects the performance of LP64 programs. So, if so, we should work on ILP32. We couldn't make kernel slower, and we ran this test specifically for it to check that ILP32 doesn't make Linux slower in LP64 mode. That's all.
But it means that you were also running in concurrently ILP32 programs.
No.
Because if there is no ILP32 program, the kernel has nothing to do with the ILP32.
It's the code, like the binary layout of the kernel slightly changes back and forth, and code gets rearranged just by applying the patch. So in some places we have to check whether we are running a 32 or 64-bit user space, and every conditional in the kernel would make a system call potentially a little bit slower.
Yeah.
But most of the effects that we see here are probably just random variations due to which cache line a specific instruction ends up in.
Okay,
And
looking at that.
this,
Because we could also have looked at the overload of marshalling and demarshalling. The overload of marshalling and demarshalling parameters when the kernel has to handle a system call from ILP32 in 64-bit mode and back. This is another story.
so there's actually the stat system call is actually going to become a little slower when ILP32 or AH32 is enabled in the future when we add the 64-bit time T, but that's independent of this patch set. But there's always variation in there. It will keep going faster and slower if we change things.
Yes. So I personally believe that 5% faster or slower at this stage is not critical, and here we see that maybe 1% or 2% difference. So it means in fact it means that there is no change.
I have a question on the previous slide. So we see varying performance across applications. Some of them have got higher performance than the other. I don't understand these benchmarks, but my question is there any analysis done as to why an application has a better performance than the others? I believe it's the nature of the application.
Yeah, so I can take this one, for example. The MCF benchmark is basically pointer chasing. If you have twice as many, if the pointers are half the size, then you need half the number of cache lines for it. You utilize your cache better, and then the program runs faster. That's one pretty obvious case. I am not aware of why anything would go slower, but that could be because the compiler is not as well optimized for 32-bit instructions as it is for 64-bit instructions, because there has been less work in it. There might be other things factoring in there, but that's the MCF is the one that has the most difference, and that's pretty well understood. And that would be the same way if you're running AH32 code on a CPU that supports it.
And MCF in 32-bit RAM is exactly a cache line. The it really kills the cache performance.
So then we are saying that it's the pointers that's predominant in this application that's doing this.
Yes, and there are other applications that do this, that have the same behavior, and it's pretty well understood which applications that are. There are, for example, important Java benchmarks. Java also does a lot of pointers.
They would try a WebKit.
WebKit, yeah.
WebKit would be a very good application benchmark because it has lots of pointers also. And by the way, we have in Linaro a specific test suite for WebKit.
Okay. So, well, this is the end and our plans. So, we have kernel and glibc patches ready and waiting for decision on upstreaming and fuse review. After that, we plan to build a distro. Maybe Linaro will help with it. Maybe Yocto distro, maybe some else. Then testing with real software, and thank you for your comments. We will take WebKit and some Java and test ILP32 with it. Then some useful debugging tools like Sanitizer or Algorithm and QEMU and whatever else we have. So I think I'm done. Thank you. This is my email for any questions.
So can we have both V7 support and ARM64 and ILP32 in a single kernel?
Yes. We made it independent. You can enable V7 support, you can enable ILP32 support, you can disable all of them independently.
There was an earlier version of the patch set which did not allow that, and we went back to the original approach which does allow it by making basically all the syscall entry points are the same between AH32 and LP32.
So I've just been looking at this, and I only really care about the configure end of this rather than the actual stuff, which is fine. So it's not currently, as far as I can tell, it doesn't work if you try and make an ILP32 only or an ILP32 with LP64 multilib. If you configure directly as ILP32, everything breaks because it assumes you're building LP64 with an ILP32 multilib, and it should work the other way around because we have a triplet for it, and it just doesn't. If you configure, yeah, GCC and glibc both seem to have. I've fixed some of it, but well, we can work on that this week. But that's basically broken. And there's the other thing is, in looking at this for kind of from a distro building point of view, I've realised that the triplet we've made is arguably kind of wrong because it's not the machine or the kernel of this ILP32, it's the ABI and the OS. So the X32 people did this the other way around, the right way around, and maybe we're being gratuitously different from X86. So anyway, there will be a discussion at the cross-distro thing later this week, unless you want to do it now, about whether it's too late to change that and we just have to put up with it. Does it mean, or whether we should fix it? But
yeah. The X32 was a really bad idea. We should not do the same.
You mean in terms of configuring?
Yeah.
Do you have more background for that?
No, it's just it has to be in the ABI. I'm just echoing his concerns that this is an ABI stuff, so it should be in the ABI section rather than in the arch name.
So it should be like X32 or no?
So X32 is at the end of the arch name, isn't it?
Yeah.
Yeah, that's wrong. It should be.
It's at the end of the alt name, which is effectively the ABI.
Yes.
So it's GNU X32. So
Exactly.
GNU underscore ILP32.
Something like that. Yeah. GNU 32.
Let me get that straight. So
and the reason why this is actually arguably worth doing is that it means you don't have to fix configure in everything in the world because it just works. At the moment, with this triplet, we will have to have config, sub, and guess updated in 1 million pieces of software to actually build stuff, which is a pain in the ass.
It's just a small comment. The first thing on the distro building, we do have a distro built against LP32 available. Today you can just get it on build-opensource.org. It's there, we're building the whole thing, but the patch is from like 1 revision last or so. We're not using the current patch set. It's still older. And for the configure stuff, back when ILP64 got introduced, we added a lot of magic into the open build service that allowed us to dynamically replace the config gas and config sub parts in all the sub packages that we're building, because we didn't want to update every single package that is around out there. And that was really handy for ILP32, because we can just go and replace it and it just works. So I'm totally personally not opposed at all against the API change. I think it's a great idea. I don't think it is too late, but our ILP32 expert is still out, so I don't know.
So I have one additional point, which is, you guys are talking about config, right? And then you set config in GCC, and GCC has whatever triple, and it could be la 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 land, whatever thing, I don't care. But in LLVM, the triple actually matters, because that's how we set up the machine and the art-specific stuff, etc. So if the triple is nonsense, then we're going to have to parse nonsense, and that's really, really bad idea.
But for Clang, you're talking about the target triple, and that would be influenced by the M32 or M64 flags, which...
Yeah.
No.
Let's postpone the triplet discussion till the cross distro buff. Yeah.
So people knew about it. So come to that session if you want to have this argument.
Yeah. So other questions and comments on ILP32 implementation, upstreaming, and so on.
Okay, I have a couple of questions, but I don't know whether they are relevant here or not, but they are relevant to ILP32. They are coming mainly from the perspective of the user. So is there a plan to support ILP32 in Clang LLVM?
Yes, and we work on it.
Okay, so I think I joined a little bit late. So, okay, I will touch base on that. The second question I have is, when is this going to be available in distros? Does the distros plan to support it in the...
Most distros never. OpenSUSE soon. No.
So the question is always whether you are looking for paid support or free, whatever is up for grabs. In an OpenSUSE world, which is our free offering, we can do whatever we like, right? We can, if there's somebody who actually wants to sit down and support it for whatever reason, I mean, we're not against anything. As soon as it comes to actually for pay distributions, it's a matter of business, as always.
11 o'clock Wednesday.
You don't see a technical...
Gentlemen, sorry, kindly sorry, but there is other session and our session looks over. So people should work too. Thank you.